All right, so let's continue. We had by isolated ants problem, right? So it was this. Okay, we have this equation, boundary value problem, where the ends of the bars are isolated so that there is no heat conduction, and the mathematical expression that corresponds to that is this one. The x derivative at the ends are 0 at all times. And we continued our solution using separation of variables. For x, we have a boundary value problem. What was that? It is this one. So before I had just x at 0 and x at L equals 0. But here, since I have u sub x derivatives for boundary conditions, that yields this x prime at 0 and L are equal to 0. And we considered the solution in 3 cases. Lambda is positive, negative, 0 and positive. All right, the third case is this. Now let's look at our conditions. Then okay, so we have, when I plug 0 for x prime, I mean in the x prime, I get this term is 0, so I have just C2 times mu cosine mu x, and this gives us C2 equals 0 because mu is non-zero. Mu is a positive number, and cosine. Okay, so I have this. When I plug 0, I have this. Okay, so C2 is 0. And this one, yeah, okay. This one gives us what? I plug L. So minus C1 mu sine mu times L is equal to 0. Since C2 is already 0, I don't write that one. Well, so to obtain a non-zero solution, okay, non-zero solution, this sine term must be 0, right? Hence, to obtain non-zero solutions, sine mu L must be 0. And this means, hence, mu L has to be n times pi, right? For some integer n. And this gives us what? Mu has to be n pi over L as usual. And I don't have just one mu, I have many mu. So let me just write it this way again. And therefore, xn is just, so C1, C2 is 0, so I have cosine terms. So these are just cosine mu n x. Therefore, this is just cosine n pi x over L. Okay, n is an integer. But you see, again, if I plug negative numbers, I get the same thing because cosine is an even function. And in this case, n is positive because mu is positive. So I can again assume it is like this. X0 was already a constant function, so I can just take it to be 1. And what about Tn? Uh, what about T? Well, the equation was for t prime plus alpha squared lambda t equals 0. So for lambda equals 0, for negative lambda there were no x. Therefore, we don't have to look for t because there should be a corresponding x function. For lambda equals 0, I had this constant function for x. What about this one? For lambda equals 0, I have just t prime is equal to 0. Therefore, t of t is again constant. Okay, constant. Therefore, so my t0, so t0 is also can be taken as constant 1, and hence u0 xt, which is x0 of x times t0 of t, is just can be taken as 1. What about the other ones? For lambda positive, then lambda is just uh, mu squared, so it is n squared, right? Lambda is just mu squared. So my equation becomes what? T prime plus alpha squared and n squared t equals 0. This is a separable equation. I can write it this way. dt over t is equal to minus n squared pi squared dt. Yes. And from this again, t and t is just e to the power minus bir dakika, lambda değildi. Okay, lambda n n squared pi squared, so it is mu n squared, so it is n pi over l squared. So we have to be careful. N pi over l squared. And from this again, t and t is just, as usual, e to the power minus n pi alpha over l squared t. Okay. So u n xt is just t n t times x n of x, and that is just e to the power minus n pi alpha over l squared t cosine n pi x over l. So hence the solution uxt is as follows. Uxt is just summation and from 0 to infinity unxt Cn un xt. So it is just C0 times U0, which is just 1, plus n from 1 to infinity, Cn e to the power minus n pi alpha over L squared t, and this time I have cosine n pi x over L. Alright, how can we determine Ci's? Well, I have to use the initial temperature distribution, initial temperature distribution, which is ux0 equals f of x, and that is equal to what? F of x equals ux0, and when I plug 0, I get just C0 plus minus, okay, so when I plug 0, exponential term becomes just 1 cosine n pi x over L. Yeah, okay. And maybe we can, choose this constant C0 over 2, okay, so that where Cn will be what? It will be just 2. So I have cosine series, so it will be 2 over L, 0 to L, f of x times cosine n pi x over L dx. Okay. Yes. So let's do one example. Okay. So let's say solve the boundary value problem. Okay. Ux(x) is equal to u sub t. U sub x, so 0t is equal to u sub x lt equals 0, and ux0 equals f of x. This is x, and L is given to be 25 centimeters. Okay, so I know that solution has this type, has this form, and Ci's are just these numbers. So we just need to compute Cn's. Okay, what is C0? It is 2 over L, 0 to L, just f of x dx, 0 to L, f of x dx. So it is 2 over 25, 0 to 25, and this is just x dx. So this is x squared over 2, 25'in karesi bölü 2. Bu da ne eder? 25. Değil mi? Evet. C0 25. Diğer Cn'ler nedir? 2 bölü L, 0 to L, f of x cosine n pi x over L dx. So it is just 2 over 25, 0 to 25. F is just x cosine n pi x over 25 dx. Alright, so this is 2 over 25. We use integration by parts. X times 25 over and pi sine n pi x over 25, 0 to 25 minus 0 to 25 1 times 25 over n pi and sine n pi x over 25 dx. So I have this. Okay, when I plug the values, when I plug 25 or 0, both of them are 0, so this term is 0. What about this one? So 25s are cancelled. I have 2 over n pi, right? 2 over n pi. I have minus sign. Integral of this is another gives another minus. So and I have also extra 25 and n pi here. Cosine n pi x over 25 evaluated at 0 and 25. Yes. So this gives us what? 50 over n pi squared. And when I plug 25, you get cosine n pi minus 1. Yes, so this is just 50 over n pi squared, and I have minus 1 to the power n minus 1. Okay. So the solution uxt, which was c2 c0 over 2, and then from 1 to infinity, e to the power minus n pi. Alpha is just 1, right? You see, alpha is just 1, right? Alpha is 1 over 25 squared t cosine n pi x over L, which is 25. And of course Cn. And Cn is this number. İsterseniz bunu şöyle de yazabiliriz. Tek çift sayıysa burası 0 olacak. And even. Tek sayısı eksi 1. Dolayısıyla burası eksi 100 bölü n pi squared. And odd. Okay. All right. Then we have wave equation. But before wave equation, let me actually consider another problem. Kaç dakikam var? Ya da wave equation'a geçeyim. Ondan sonra bir değişik bir problemden daha bahsedeceğim. Ya da şöyle diyeyim. Şöyle bir örnek daha yapalım. Solve the equation boundary value problem. Şöyle olsun. Alpha squared ya da şöyle diyeyim. 1 artı t kare u sub x equals ut. U 0 t equals 0. U lt equals 0. And u 0 pardon x 0 equals let's say 20 and L de şey olsun 50 centimeters olsun. Bu biraz daha farklı bir heat equation. Bizim alfamız constant değil bu durumda. 1 artı t kare. Yani bir yerde şey gibi düşünebilirsiniz. Cismin ısı geçirgenliği zamana göre değişiyor. Zaman arttıkça ısı geçirgenliği artıyor gibi. Veya azalıyor. Çok emin değilim. Nasıl çözeriz bunu? Again we use separation of variables. Use separation of variables. So I consider this kind of solutions. And as usual, we take derivatives, u sub x prime t, u sub x double prime t, and u sub t is just x times t prime. And when I plug this into the equation, I get 1 plus t squared x double prime times t is equal to x times t prime. And from this, we get x double prime, over x is equal to 1 over 1 plus t squared t prime over t. As usual, this is a function of x, this is a function of t. They are both equal, to each other. That is only possible if both of them are equal to the same constant, let's say minus lambda. And from this, as usual, we obtain this gadget. And again, since I have homogeneous boundary conditions, that would imply homogeneous boundary conditions here also. So that's a 2-point boundary value problem. And for t of t, I have t prime plus t times, lambda times 1 plus t squared, t equals 0. Well, we already considered this, right? This gives us what? Lambda should be n pi over L squared, and from ranging from 1 to infinity integers, lambda n, and xn of x is just sine n pi x over L. Okay. What about the corresponding tn's? So t prime n plus lambda n, 1 plus t squared tn equals 0. So this gives us what? Again, this is a separable equation. So dtn prime over tn is what? I take this to the other side and divide by tn and take dt to this side. So I have 1 plus t squared over dt. Bu tam da istediğim şey değil aslında ama neyse. Okey, sorun değil. Şurada bir eksi var değil mi? Eksi var. Tamam, şöyle. Yok, tamam. Buradan ne elde edelim? İntegralini alırsak t is e to the power. Yani önünde bir c var ama c'yi boş verin. Çünkü sonradan zaten o constantlar gelecek. E to the power minus 1 plus t squared yok. Bunun integralini alacağım. Bunun integrali nedir? Bir dakika, dikkatli olalım. Buradan ln tn, bunun integrali eksi t artı t küp bölü 3 değil mi? Artı c var. C'yi boş verin. Dolayısıyla tnt şöyle bir şey çıkacak. E üzeri eksi t artı t t küp bölü 3. Evet. Çarpı bir c var. Dolayısıyla da un x t x n of x times t n t. So this is e to the power minus t plus t cubed over 3 and then sine n pi x over L. So uxt is then summation from 1 to infinity bn e to the power minus t plus t cubed over 3 sine n pi x over L. What are these bn's? I need to use initial temperature distribution. Ux0 equals f of x, and f of x was given to be 20. So when I plug 0 here, okay, when I plug 0 here for t, I just get e to the power 0, which is 1. So summation from 1 to infinity bn times sine n pi x over L is equal to 20. Okay, so what is bn then? Bn is just 2. So I need to write sine series of this function, constant function. So it is 2 over L, 0 to L, f of x sine n pi x over L dx. So it is 2 over L, and then I have f de 20 idi. 20'yi aldım. Bunun integrali de eksi L bölü N pi değil mi? Kosinüs N pi x over L 0 to L. So Bn is 20 times bir dakika, L 50 idi. Şurası 50 olacak. 2 bölü 50 50. Bu 20 nereden geldi? F'den. F 20. Tamam. L 50. Dolayısıyla şimdi burası ne oldu? 4 bölü 5 çarpı 4 bölü 5 çarpı eksi 50 bölü n pi kosinüs L yerine pardon, x yerine L yazarsak n pi gelecek. Kosinüs n pi eksi 1 as usual. Dolayısıyla burası eksi 40 bölü n pi eksi 1 üzeri n eksi 1. Yani n evensa 0, oddsa da 280 bölü n pi. Çözümümüz de şu. Uxt is n from 1 to infinity bn e to the power minus t plus t cubed over 3 times sine n pi x over L. Okay, so that's the solution, I guess. Yes. Peki, bir de şöyle bir örneğe bakalım. Another example. Ya da evet. solve the boundary value problem. Şöyle bir problem olsun. Alpha squared uxx is equal to ut. U0L is equal to 0. Ama burada bir de şey olsun. E, şöyle olsun. Pardon 0t L 0 equals 0 and ux 0 equals f of x. So this time one end is isolated, the other end is kept at 0. So uh, the uh, one of the ends of the bar is isolated and the other end is kept at temperature 0, at 0 temperature. Okay, how can we solve this? Well, let's see. Again, we will use separation of variables. So I have x of x times t of t, and this gives us the same equations as usual. I will not write down all the details. So x double prime plus lambda x equals 0 and t prime plus neydi o? Alpha squared t equals alpha squared lambda t equals 0. Evet. And what about the initial conditions? Boundary conditions. U sub x would give us this. X prime 0 is equal to 0. And UL gives us this. So one condition is in terms of the derivative, but the other one is not. Okay, so I have this boundary value problem. How can we solve this? Well, we write down its characteristic equation as usual. So it is just, sorry. Okay, bir dakika. Şöyle yapayım. Pardon. Yazdım, ekran gene çöktü. Okay, şöyle yapayım. Kaydı bir durdurayım da.